So first off, let's just look at what we're going to see for part B. We're going to determine the pH using a couple different techniques, including the red cabbage juice from part A, and then the other one's going to be pH paper, and you'll see that shown in just a few minutes. And first off, I just want to go down, through the list here and just show you what I'm looking at in front of me. And what I'm going to do is I'm going to, take a sample of each one of these solutions and place it in a spot plate. That's just a little dish that holds a small volume of a sample, and then I'm going to test for the pH of each solution a couple of different ways. Okay, and I should make note here that, and you will make this correction on your lab or change, instead of apple juice, I have grape juice, and so that's what we're going to use for the pH test. Okay, so the first one we're going to do is actually using the pH paper. So what I've done here is I've just dispensed a little bit of each of the solutions into the spot plate. The spot plate is just a dish that can hold about a 1 milliliter sample of each of the household items. And the way I have them arranged here is starting from top to bottom. You have the vinegar, the ammonia, the lemon juice, not apple juice but grape juice in this example. This is the shampoo. This is the detergent, Tide detergent. This is hair conditioner. This is mouthwash, antacid, specifically Rolaids, and then a solution of aspirin. And then these last two are blank here. First thing I'm going to do is determine the pH of the solution using pH paper. And so over here, instead of using a pH meter, what we're going to do is we're actually going to use pH paper to determine the pH of the solution. Now I'm not going to write down the pH. I'm going to let you do that. Okay, I'm going to do the experiment. I'm going to show you the color change, show you the key, and then you can determine what pH each of these solutions are at. So pH paper, it's paper. There's two different colors. There's orange and there's blue, and you start out with the orange side, and here's the scale for the orange, and a bit similar to the cabbage juice colors. If the orange paper turns a dark red, then that indicates there's around pH of 1. And if it turns a purple, it would be a pH of 12 or greater, because with the pH paper, we also have blue paper. So if we max out at this dark purple here, then what we'll do is we'll take a piece of the blue paper out and then use that back side of the scale to then narrow down how basic the solution actually is. So the blue paper is a little bit more, has a higher degree of accuracy in a smaller pH range. Not a lot of the samples will actually be with the blue pH. Okay, so what I'm going to do is again take a piece of orange paper out and do the pH determination. So first, let me just demo the proper way to determine the pH using the pH paper. So you don't want to dip the pH paper into the solution. You contaminate the solution. If you're going to use that solution for something else, it's just been contaminated. Instead, what you want to do is take a clean glass stir rod, and just dip it into the solution. That'll grab a drop or so, and just simply touch it to the pH paper, and you're done. Well, you're done except for then matching up the color. And so remember, that's the vinegar solution. Now vinegar, you may already know, is an acidic solution, so we should anticipate a lower pH, and we do see that, and I'll let you be the judge exactly what pH you have there. Here's the ammonia solution. It's turning pretty dark. Now, my judgment is that is not all the way to 12. It's definitely a basic solution. I'll let you decide which one you want to call it. Okay. Here is the lemon juice. So lemon juice is acidic, so we should anticipate a lower pH. I don't think it's quite as red as the vinegar. Here is the grape juice. Just a very slight change. Next one is the shampoo. Actually, that's the one I should have said, very slight change. We look at that one. Yeah. It doesn't quite have the yellow coloration to the 7, so I'll let you judge one of those. This is the detergent. Okay. Yep, there we go. Clearly between 8 and 9, somewhere in that range. This one is the conditioner, hair conditioner. It looks very similar to the shampoo. Now it's the mouthwash. Again, this isn't surprising me too much. You know, you are putting this, you're rinsing your mouth out with this. This is not something you would want to have a really high or low pH range, okay, or pH value. And by the way, I'm cleaning off the glass jar rod in between each of the tests here, so it's nice and clean. Antacid. So antacids are designed to neutralize acid in your stomach, so should anticipate this is going to be a bit basic, and we do see that. Back in that green coloration. From what I'm looking at, it's a lighter green than one of the others at least. And our last one is going to be the aspirin solution. So I'm not sure how well this is being picked up on the camera, but this is not a pH of 1. Okay, it's more in the 2 or 3 range there. Now next what I want to do is use the, well, there'll be two different observations here, okay? The color of the indicator, and so when we say indicator, this is just going to be the cabbage juice, okay? And so what you'll do is first we'll observe the color change when I add the cabbage juice, and then based on that and the pH scale from part A, then you're going to take the color that indicated, like with the vinegar, and then do an approximate pH value based on the color change from part A. Okay, and I'll demo that a little bit too. But first off, let's just add the cabbage juice to each one of these samples so we can see the color changes. And by the way, I am cleaning off in between each solution, so I minimize the contamination. Okay, so there's our different colors. So now what you can do is you can just use the image from part A, match up the color, and then do an approximate value for the pH.